In this problem, we're going to find the voltage V0. If you look at this circuit, you'll see that it's a single node pair circuit, only two nodes. Also, it has a dependent current source, and as a result, we're going to use the problem solving strategies for single node pair circuits and for circuits with dependent sources. If we look at our circuit, since it's single node pair, we know there's only one voltage. We're already assigned the voltage V0, so there's our voltage. Our second step is to assign currents to all the resistors using Ohm's law and the assigned voltage. Okay, so this current is V0 over 4K, V0 over 6K in that direction. Again, the directions are coming from Ohm's law. V0 over 12K is that current. Now we need to apply KCL at one of the two nodes. So we're going to have one equation. We want to write that equation in terms of V0. So I'm going to apply KCL to the top node, and I'm going to assign, or I'm going to sum currents leaving that node and set them equal to 0. And by our problem solving strategy for circuits with dependent sources, I'm going to treat this as an independent source and writing the equation. So summing currents leaving, setting them equal to 0. We have V0 over 4K. There's 6 milliamps entering. That's minus 6 milliamps leaving. Here's the current leaving. That's V0 over 6K. This current is entering, so that's minus 0.5 Ix plus V0 over 12K equal to 0. So there's our KCL equation. Now let's collect terms, simplify a little bit. So we have V0 1 over 4K plus 1 over 6K plus 1 over 12K minus 0.5 Ix is equal to 6 milliamps. Now if we look at our circuit, we see, for instance, that Ix is equal to V0 over 4K. So now if we make that substitution, we would have that. Now, let's continue to simplify. And if we look, we have 1 over 4K and minus 0.5 over 4K. So we could rewrite this as 0.5 over 4K plus 1 over 6K plus 1 over 12K is equal to 6 milliamps. And if you go through and solve, this turns out to be V0 equal to 16 volts.